Welcome to the car tutorial. So this is the car. As you can see, I already organized the geometries a bit in groups. So we don't constrain anything to the groups themselves. This is just for keeping things a little bit more organized in the outliner, but we will drive each geometry individually. So we have the car body, which is the main part. We have the steering wheel. We have the back wheels, which I combined to one object because they're spinning with the same speed and do not steer individually. The front left and front right. I have a group here with the doors. This is again just for organization, but we're not going to move that group. It's just there in space. Okay, so I collapse all that because I don't need that for now. So first things first, we need to create controls. So when you see the video on the assessment page, you see the controls that I'm using there. I'm going to create something similar for this setup here. So I need my grid. The grid is down here, so it looks like this model is rather large. That's probably real world because these are centimeters actually. So I leave it like that. It's actually better that way. But for drawing controls, I will zoom in here so it's easier to snap to specific points. Okay, I'm creating in the modeling. I'm going to make a curve. Oops. EP curve options. And I switch to linear and then I turn on grid snap. So first things first, the car, the root control. So basically elongated rectangle there. That's number one. Call that root control. To get it out of the way, I just scale it up. Then I repeat that process. Here my last tool is always here on the left hand side. Just click on that again. Let's make that banking frame tool, which is a square. So that's banking, tilting, or whatever you call it. I call it tilt. Tilt control frame. I need a circle in there. You can also make a small square actually. Well, let's do that just for a change. So I'm choosing a smaller square. Oops, duplicate it first. Smaller square, and then we call this the tilt control. Let's select these two and freeze the transform. Make sure that everything is turned on. In my case it's not, so turn it on and freeze transform. So I make the tilt control a child of the tilt control frame, like so. So that whenever I take this guy and move it around or scale it, the other one comes along. Okay, let's make it bigger, quite a bit. So just so it's out of the way. Next one is the steering control. Again, I'm using this last tool from the left hand side, and I'm going to create an arrow here. And don't forget, you have to make points on every step, otherwise you will not be able to bend it. Same on the other side, every grid point needs to have a point of the curve. So in the end it looks like this. Let's bend this thing using a deformer, which you find in rigging or animation. Deform non-linear bend. The bend curvature, just set any value for now, and then change the orientation so that the bend actually goes this way. I'm holding down J to rotate this in 15-degree steps, and then again this way. And there you have it. The curvature is a bit too strong, so I go a little bit down here. Okay, and then we need to destroy the history, because currently it's still connected to the deformer, so whenever I change the orientation of my curve, it gets deformed in real time. Not what I want. So select that curve, go into edit, and then delete by type history, or shortcut Alt Shift D. And that removes the deformer, and now the curve is independent. So let's rotate it already. Hold down J, so we can rotate it by 90 degrees. And again, scale it up so it's out of the way. So what else? We need controls for the wheels, but we can do that later. So let's get everything in place when it comes to the controls. So we have this guy here, which is already in the right size. So let's move it just somewhere where it's useful. The root control is down there, it's a bit too small, so let's scale it up. Move it, scale it a bit more. Yeah, just like that. Then the steering control, which is down there. Just bring that up, forward, and here. Oops. Little bit down maybe. I still have a snap turned on, that's the reason why it's moving so weirdly. So let's turn that off. Okay, I think I leave it where it is, and the size I like as well. Okay, once we have moved everything, we need to reset the transform, because we don't like these scale and transform values. So select all of your controls, and then go into modify, freeze transform. Also rename your curves. So this one here is the steering control. So the steering control is going to be a child of the root control. But before we do that, let's bring the pivot of the root control down to the back axis of the car, because that's where the car rotates around. It would look weird if it rotates in the center. That makes the tires slide. So hold down G, Dora, and then shift that point backwards. You might want to switch to a different view to see that a bit better. So D is just basically underneath that axis here. Okay, so with that done, let's parent this under that, and we parent this guy under that. Hit P again. So if we take this root control and move it, both of these controls should come along. One thing we might want to do is the rotation point of this control is currently here in the middle. If you rotate that, it will look like this. That's not a big deal, but I prefer it to move like a cylinder, so I move it a little bit further down here. So hold down D to move the pivot, and then when you rotate, it looks more like steering. It's just a aesthetic thing. What we can do here is change already the locks on the channels. So right now this thing can rotate in all directions and of course move as well, and scale. Not what we want. I just want this to rotate around the y-axis. So let's select all the other channels except rotate y. Right click it and lock and hide. You can do the same for this guy here, which again should only move in Z and X axis. So select all the other channels except translate X and Z and lock and hide. For the root control, we want to be able to move it in all directions and rotate it even in all directions, but we don't want to scale it. So select that and the visibility and lock and hide. Let's make the controls for the wheels. We know that we want to spin them both separately, so we can do a burnout effect so that the front wheels rotate slower than the back wheels. For that I need a curve, a circle curve. So create, where is it, curves. Okay, NURBS, primitive circle, there it is. So let's scale this up. Hold down J and rotate it by 90 degrees. Switch to the front view. Place this precisely over that wheel. You can use point snap for that. Hold down V for point snap, and then scale it to the right size, which is just eyeballing. Doesn't have to be, I mean, it can also be smaller, but you know, let's make it a bit smaller. Why not? So it's easier to select, we move it a bit outwards. Okay. Freeze and transform again. Modify, freeze and transformations. And we call this the front wheel spin control. We duplicate this one and move it to the back. Again, use the point snap to snap it precisely to that point in the center. With these values here we don't like, we do our freeze and freeze of transformations. Here you go. And this is of course the back wheel, or back wheels because it's multiple wheels. So there you go, back wheels spin. Both of these controls should be parented to the root again. So middle mouse drag them onto the root. So this is what it looks like. Time to save. So I give it a nice name, Copper Rig Controls version 1. So you should always save multiple versions. Don't overwrite them all the time, because you might make a mistake in the rigging process and then you want to go back to an earlier version. If you always overwrite the same file, you will not be able to do that. One thing I forgot, of course we do not want to be able to rotate this in all directions. So we have to lock and hide the channels that we don't want. So in this case, all I want is rotate Z. So I mark all the channels that I don't want, right click, lock and hide. The same for this guy, it's the same channel, so rotate Z, skip, the rest is being selected, lock and hide. Okay, so that's better. So for visual help, I'm going to distribute the controls into a layer here, so we can choose a different color for them. So let me select the root control, or a matter of fact, let's make a group over the root control and call that group controls. And this group I throw into a layer by clicking on this icon here. That layer is called controls, or just control layer. I'll give it a nice color, like yellow for example. Now you see it much better that what is control and what is geo. Okay, we can also put the geos already in a group. That helps to prevent accidentally selecting things. So I call this group the geo group, or geo layer rather. I can switch that to reference, or even template if you want to. Template is wireframe only, even in shaded mode. Reference is shaded, but you can't select it. So if I switch to shaded mode, you still see the geometry, but there's no way for selecting it. But we can still snap objects onto the mesh. Or you want to switch to template, which is unfortunately the same color as the background, which I do have to change in this case. So let me switch quickly switch the color for the viewport to something different. And we can also make it black actually. Why not? Or maybe not quite black. A little brighter, like so. Okay. So next thing is joint structure. The joint structure will drive pretty much everything in here, and we use the geometry for placement as a guide. Okay, so let's switch to the front view. And I'm turning off the grid because that's too small, or maybe I change the grid settings here by right clicking on this grid icon. You can go into the grid options and change the values here. So the reason why this is so small, this is not actually the default. So this is more like it. Okay. And here, this is my origin. Okay, so I'm going to place a skeleton joint. So skeleton, create joints, and I can place it really anywhere, but I'm going to place it right in the center of the car, like here in the middle where the seats are, and then hit enter. And again, I seem to have joints is on, but I still don't see them. Why? So the joint is actually there, but it is also rather dark against the background. So let me change the background color again. Color settings. Yeah, so let's go for something that is more to the default. Okay, and even when the joints are a little bit too small, you can always go here into the display and find in the animation menu the joint size setting, which gives you this little dialog with a slider, and that one changes the overall size of joints globally. So in this case, I actually need to make this quite big. Okay, so here we have our joint. This joint, immediately call it root joint. Now we need several joints distributed all over the model, which basically are our axis for certain rotations. So let me make a duplicate of this guy, Control D, and then we move it there. Now you see it disappears because of the mesh, but we have this X-ray joint mode, so just click on that. That makes joints always visible, no matter if they're behind something or not. And let me just snap that again to the center, holding down V, so point snap. So this is going to be my back axle joint. And the position of that joint doesn't really matter. It can be here, it can be there. I just put it here in the middle because it influences both wheels, and to make that clear, we just place it in the center. So I just type in a value of 0. That makes it perfectly centered. I need another one for the front, or actually two. So let's make a duplicate, move it all the way to the front. Again, you can hold down V to snap it to the center. Then we better look at the model from the bottom. So this is going to be my steering axis. And steering happens somewhere in this space here. So I just align it against the tire, on the inside of the tire. So this is my, which one is this? This is the left front wheel steering joint. I make a duplicate again, maybe to the other end. So the distance again doesn't matter, because this is just for the spin of the wheel. It can be here, it can be there, it doesn't matter. But I just place it here, so for view the left front wheel spin joint. And this is going to be a child of the steering one. The moment you middle mouse drag it into the other joint, you get this connection, this link. And this guy can rotate out, while this guy is responsible for the spin. I want to mirror this over to the other side. So I'm selecting my left front wheel steering joint and then mirror joints options. The axis I'm going to mirror is X and Y. So X, Y. You want to use orientation mirror. So when I turn this forward, this should go backwards. And we search for left and replace it with right. So left underscore, replace it with right underscore, and mirror. So there we have it. Both of these are going to be a child of the root joint. So middle mouse drag it onto the root, and if we hide the geo layer for now and also the animation curves, we don't need them right now. You see what happened. So here's my root, which, by the way, let me make this a bit bigger so it's a bit clearer what is root. So these are connected to the root, and this one here also needs to be connected to the root. So just middle mouse drag it onto the joint, the root joint, and it will automatically create this link. Okay, what else? The banking. So the tilting and banking of the car. Since this is going to happen on 4 different points, or rather 2, basically think about it as like a box being underneath here, and this is where the springs, the suspension is being hooked up. That's why the car can only, or the body of the car can only tilt in certain points. And again, these points will be defined by joints, joint positions. So I go back to my front view. And let's just make a new joint using the skeleton create joint tool. And I click somewhere in the viewport so it's easy to select. Might want to change the radius so it's a bit easier to see. So one of the points I want to bank around is here on that very end of the wheel. And I'm using the same point for one of the left sideways banking. So I'm going into the left view and move it towards roughly somewhere here. So I call this the front left tilt, or body tilt make a duplicate of that, move it to the other side so it's symmetrical. Go to the front view and move that to the back, just like here. And this is going to be the back right body tilt joint. So let me hide the geometry again, hide the grid. So this guy is going to be connected to the root. So middle mouse drag it onto the root. And this guy is going to be connected to that first tilt. So now this looks a bit weird, but this is basically what it does. When I select this guy, I can tilt in this axis, and I can tilt in this axis. When I select this guy, I can tilt in this axis and in this axis. So that's the idea. So let's bring the geometry back, and maybe it's a good time to save at this point, because now we have already our joints. So I call this Cobra Rig Joints version 2. So you see, these are like basically building groups. One is the controls, one is of course the geo, which we already got from the modeler, one is the controls that we made, and the last one is the joints. And now we have to wire things up. So let's group that and name this joints. This is currently sorted alphabetically. Okay. To wire things up, let's make also the controls visible, or maybe hide the geometry for now. So basically the root is coming along with the root control. So we select the root control, and then control select the root joint, and then we make a parent constraint. That already solves most of the requirements. Let's do the wiring for the steering. I'm taking this control and turn it, let's say 30. Yeah, so let's turn that 30 degrees, and then we steer full max on this steering. Okay, so first we go to 0 and select our 2 steering joints, or actually just one, the left one. And the one axis that I want to use is this one here, which is to rotate Y. Okay, so undo, we'll be back to 0. So rotate Y, select that in the channel box, and then set driven key. Then we need a driver, which is this control here. So load driver, and select the channel, rotate Y. And on 0 we have a key. Now we go to 30, and then we select the joint and we rotate it let's say 35 and key. And then we take this guy and rotate it the other way around, so -30 and then this will be -35 and key. So that should do the trick. Of course, currently I can rotate it all the way, not what I want. So let's put a limit on the rotation. So go to the attribute editor, into the transform tab, limit information, rotate. Here we want to go from -30 to +30. Okay, so now I have my limits here. Let's zero that. So let's actually attach this wheel, the geometry, to this spinning joint. So select that joint and shift select the geometry, or you can't probably because we are in reference mode here with this layer. So remove the reference and then shift select it. So we want a parent constraint for this. Because now when we steer, we actually see something. The other axis is currently not steering. We can just select this joint and shift select that joint and make a direct connection in the node editor. So here we have it. The left, this one controls the right one. And the thing we control is rotate Y in both cases. So click on the Y dot output, rotate Y, goes into rotate Y. So immediately it should work. There you go. So let's connect the geometry as well to this one here. First select that joint, the spin joint, and the wheel second, and then constraint parent. See if that works. Works. Let's constrain the rotation of this joint, this control, to this spin. Actually, matter of fact, to that and that at the same time. Okay, so I'm selecting these two spin joints plus that spin control, and I can go into the node editor again. Let's clear it out first and then bring in those nodes. So the control is going to control the rotation of those two. We don't need a shape. So if I select that control, I see I have rotate set only as available channel. So that's the one we want. And then for the joints, it's probably also rotate set. can test this. Yeah, there you go. So we take that, rotate Z, so it's out of the frame, rotate Z, and connect it to rotate Z. Same here. Rotate Z goes into rotate Z. That should do the trick. Let's check the other side. Works. Let's do a similar thing for this joint and that control. Clear out again, bring those two nodes in. Don't need the shape. Control drives the joint. Again, the axis is rotate Z and probably also rotate Z on the other one, so let's just assume that is correct. And then test it. And as you can see, the joint is spinning, but the wheels are not, because they are still not constrained to that joint. Okay, so let's zero this out. We select that joint and then shift select the axis, the back wheels, and we make another parent constraint. So now they're spinning. Okay, now we have to connect that control here to the banking of those two joints. And before we do that, I would like to constrain the actual geometry to this joint here, so we see better what we do. Okay, so I select that joint, and then I find the body, and do not choose the body group because that would be too much. You just find the geo here. So control click that one, and then we do a parent constraint. Okay, so what's going to happen is the doors will not come along, as you can see, but that's not a problem, because later on we will make joints to all these doors and have their individual rotation as well, so we can open up the doors, and because they're going to be a child of this joint here, that's why they will come along later on. But now we just need to zero this out. Okay, so let's do one by one. So this guy can rotate in this axis, and that is to rotate X. So select rotate X and then go into set driven keys. Select that control and make it your driver. The value we want to currently drive is the translate Z. Okay, so translate Z drives rotate X. And in this position, in the neutral position, we put a key down. And then we move this all the way to the max. So I haven't actually put any limits here, so that is a mistake I made. but it's never too late. So let's do that now. I go from -80 to +80. In this case, because of the size of my scene, for you it might be smaller values. And probably the same for the other axis. So I type in the values already. If I move all the way there, that works. Move all the way there, it works. So that was correct. So I go to the -80, and then I adjust the rotation of this joint. Let's do a -4. And then we put a key. So if I take my control now and move it back to the center, we have this rotation. Let's bring this value back to 0. And we select this joint and make it our driven. And this one is probably also rotate X. Okay, so we select rotate X and translate Z on our control. And again, in a neutral position, we put a key down, then move the slider to the extreme and select our joint, or it's just selected here in the Z-driven key interface, and rotate it by +4 degrees and set a key. So as you can see, at neutral, both of these values of these joints have 0 rotation. I go to the right, this one rotates, and I go back to 0. Both are neutral on 0, and then when I move to the left, this one rotates. So that way I can rotate multiple objects with one controller. Okay, let's bring that back to 0. Now for the forwards and backwards tilting. I select this control here, which is already here loaded as a driver. This time I'm going to rotate around this axis. Okay, so that's rotate Z. So select it in the driven section. And it's going to be translate X that drives it, so the red one. So translate X of the slider drives the rotate Z of the joint. And in neutral position we put a key down. Then I move it to the extreme and select my joint, and then I rotate it to a value that makes sense, which is 2.5. Maybe 3. Yeah. Then put a key down. Test it. So 0. And everything in the negative area does nothing. And then when I get from 0 to the positive area forward, this thing is tilting. Okay, let's bring it back to the neutral position, which is in the center. And then we need to select this joint again and make it our driven. And we already know it's the rotate set because it's always both the same. In a neutral position, we put down a key. Then we move this to the extreme, and then we rotate this to our liking, which is a little bit less than the other one. So let's say -2. And for the key, we can change that anytime if we feel that this is not enough. So that would be the banking. Okay, works. So we have spinning wheels, we have steering, we have banking and tilting. This one is moving the geometry along. So when we move things, only the things that we haven't connected, the doors and the steering wheel, will stay in place. That's because we don't have any joints currently that drive their position. So we have to make joints for the steering wheel and for each of the doors. So basically 5. 2 sideways doors, 2 on the back and the front, and the steering wheel. So for pretty much every of these joints, the orientation is world space is perfectly fine, because we want to either rotate it along the y-axis or along the z-axis for these two, with one exception, the steering wheel. The steering wheel has a little angle here, and for that we will not just use a simple single joint, but actually making 2. But so let's have a look how that works. First I switch to front view, and I'm creating a new joint. Create joint. I'll just place it anywhere for now. Make it slightly bit bigger maybe. Yeah. So this one, let's say this one is for the door. So I just basically place it where the hinge would be, which is basically just here on the gap between the main body and the door. And of course it has to be, so we just move it over here to the door, and that works probably best in the top view. Somewhere here. I can name this driver's door joint. Then I make a duplicate, move it all the way to the other side. Of course I could have mirrored it as well, but that's fine. Passenger's door joint. I make a duplicate, and that duplicate I'm going to move to the center, so put a set value of 0, and I move that there where the hinge for the hood would be, so somewhere here on that gap. I call this the hood door joint. Make another duplicate and move it to the connection on the boot, and we call that the boot door joint. They're probably not in the right height, so we need to move them. So this guy needs to be here, and this guy needs to be somewhere here. Okay. So that's the lower joints. All of these joints will be a child of the root joint. So just middle mouse drag it onto the root joint. And as you can see, it creates these links. And now things start to become a bit messy. So it's a bit easier to see if you make the root joint a bit smaller. So I scale down on the radius value. So everything is connected to the root. Because when we move the control, which controls the root joint, you see everything comes along. Actually, matter of fact, I made a mistake. These joints need to be pounded to this joint here. So not the root. So shift select this joint here and then hit P. Otherwise the banking will not be transferred into these joints. So let's test if the banking actually goes in. There you go. That's what we need. Now we want to constrain our geometries to those joints. Let's find all these joints which are somewhere here. So we have the driver, passenger door, hood and boot. So since I'm already here, select the hood first, shift select the geometry and then parent constrain it. Do the same for the driver door, G. The same for the passenger door, G. And lastly the boot, and G. G is always repeating the last operation, which was making a parent constraint. So if I change the banking of my car, everything should come along now. I forgot the steering wheel though. This is not coming along yet. Okay, steering wheel. For that we switch to the front view and into wireframe, because we need to see the angle of the axis here, this one. And in order to get a joint that already has the right orientation, we make two joints. So create join, click on the center of that cylinder here. You just eyeball it, but be precise as possible. And then place it right there. And then place the next one on the center of this axis. Now I have very large joints here, so it's a bit hard to see. So I'm actually going to use this link triangle to hit the middle there. So what you end up with, once you're done, so hit enter, is a joint that already has its x-axis perfectly straightened out to match with our steering wheel. So the second joint, this one here, we don't need. We can delete it now, because that was only to help us find the axis for this joint here. Now the placement of it is not quite right. It needs to be moved to the side, and we can use the top view for that. Again, we eyeball it to be rather in the center. And this one controls the steering wheel, so we just shift select the steering wheel. Oops. Not what I wanted. So shift select. See, this is why wireframe is not best mode here. Shift select the steering wheel. And then do a parent constraint again, so that this guy, when it rotates, will rotate the steering wheel mesh. Now it has to be a child of this joint as well, so it gets the banking and tilting. So shift select the bank tilt joint and hit P. So let's test that. Okay, works. So when I steer with this control, I want this steering wheel to rotate as well. So first let's get it to 0, and we select that joint. The joint that we want to, or the axis that we want to rotate, is the x-axis. So let's select rotate x and then set driven key. We load the steering control as our driver and choose the only option that we have as a channel, and put a key down for the 0 position. Then we steer all the way to the left, select that joint, and then rotate as many turns as we want. So I'm going to 70. Key. Then I do the other side as well, and this time minus to 70. Key. Let's test it. Works. Zero. It is already possible to rotate those joints here to open up the door. Now the question is, where do we put this in these parameters to control these individual doors? Because they're not that important and the animator is not touching them all the time, I just put them as extra attributes on the root control. So I select my root control, and it currently can only do translate and rotate. Well, let's just add more attributes. Let's call one the driver's door. It's a float from 0 to 1, 0 being closed, 1 being open. Add passengers underscore door, same thing, 0, 1, add. Boot, same thing, 0 to 1, add. Hood, 0 to 1, and OK. So now we have these values, and all of them can go all the way to 1 and 0. So that's all there is. And each of these drive the rotation of one of these joints. Okay, so this one rotate around set. Select that channel and set driven key. The driver is our root control. Load it, and then choose the right parameter, which is in this case the boot. Put a key down. Then change the boot value to 1 and change the rotate set value to how far you want this to be opened. Like so much, maybe. Let's give it a nice number, so 70 it is, and then key. Let's repeat the process for the other joints. The hood, let's load driven. It's probably again the rotation around the z-axis. You see that red is X, green is Y, and the one that's currently selected is yellow. You can also select something else to make it blue. So that's the z-axis. This is going to be driven by the hood parameter, and in its current state we put a key down. Then we change the hood value to max, which is 1, and then we change the hood joint rotation to max, something like that. Again, might want to use a full value, so -40, key. Then the driver's door, load driven. This one wants to rotate around the y-axis, so rotate y. It's the driver's door though, parameter, key. We change the driver's door value to 1, and then we change the rotate y to something we like. So what's that? -60. Key. For this joint, load driven, rotate y, passenger door, key. Select the passenger door value and increase it to max. Select the joint and rotate it to 60. So it's symmetric with the other door, and key, and that's it. So let's see, when we select the control, the root control, and check all these values and change them, everything is working. And if we move this control, everything comes along as well, because it's connected to the tilt joint. We can spin the back wheels, we can spin the front wheels, we can steer. When we spin the front wheels, when it's turned, it's still working on both sides. And the root control is bringing everything along. Okay, all good. We have already the geo on a geo layer, which we can put into reference mode, so we don't accidentally select it. So what's left is house cleaning. So we have joints, we have controls, and we have the geos. The joints we don't want to see, so we hit H and hide them. The joints and the geos is something that the animator is not allowed to touch, so we make a group and call it do not touch. And then that plus the controls grouped together is our rig, which is called Corvette. Just looked it up. It's not a Corvette, it's a Shelby underscore Cobra. So that's the name of that car. And there you have it. So So with this setup, we can select all the controls and zero them out, and that brings them back to its original position. One last thing I would like to change, because I just noticed the frame, this one here, we don't want to be able to select that. So to prevent this frame from being selected, the only thing that we actually want to select is this control. We can either put that also in the geo layer, or we can go into the attribute editor and change on the transform the display settings for this. So display, overrides, then enable overrides, and then here you can switch it to reference. That overrides also the control. Okay, not what we want. Undo. Let's do that on the shape rather. Object display, drawing override, reference. Yeah. So if you do it on the shape, it's really just limited to the frame itself. If you do it on the transform, the children, which this object here, will inherit that attribute unless you override it as well. So it's easier to put it on the shape then. Okay, there you go, fully ready.